So data transformation, we looked at ranking. Ranking is very clear. We know that that's used for ordering data, assigning positions to data items in order, either in ascending or descending order. The mean mass transformation, that's the formula there. Okay. We said it's one of the most common ways to normalize data. And for every feature, that's for every column, the minimum value of that feature gets transformed into 0. The maximum value gets transformed into 1. And every other value gets transformed into a decimal between 0 and 1. So that's the formula there. The new number, the result is assigned x minus mean divided by maximum minus minimum for that particular column. That's exactly what we did just now in Excel. Decimally scaled values, decimally scaled scores is computed by dividing each item in a set by 10 to the power of c, where c is the value that brings the maximum absolute value to a value less than or equals 1, which is what we did. Decimally scaled scores is used to bring all values to a range of -1 to +1. Okay, so x new is assigned x divided by 10 to the power of c. So you just need to know, be able to choose an appropriate value for c. That's all. That's all you need to understand there, which we just did. Okay, so like I said, c is a whole number, either 1, 2, 3, 4. C is a whole number, not this, not like 1.5 or something. No. Z-score. A Z-score is a standardized score. It measures how many standard deviations a data point is from the mean in a distribution. What's the formula? Z is equals x minus mean all over standard deviation. Does this make it clearer now? Okay, so this is what we just did. The practical demonstration in Excel is what we just concluded. Before I display this slide now, we looked at simple ranking, we looked at mean mass transformation, we looked at decimally scaled transformation, and then Z-score transformation. What we are calling transformation can also be called normalization. Okay, you can see that this ranking is actually not called transformation as such. Okay. Now, for Z-score, I was telling you, Z-score is based on normal distribution. It's based on this. You can see in a normal distribution, at the center, you have 0, then you have this one here is like a standard deviation. These two is like 2 standard deviations, 3 standard deviations. Okay, so you can see the Z value is not likely to fall outside of this range. In fact, most times it doesn't even go between like -2 to +2. Okay. Let me show the Excel computations again. You can see as these core values, you can see the kind of values we have there. You can see 1 point something, 0 point something. We don't even have 2 here. Why? Because most of the values in a normal distribution concentrate around the center, around 0. So that is that for data transformation, which is also called what?
Normalization.
Thank you. Also called data normalization. So is this clear to every one of us? Is it clear?
Yes, sir. Yes, sir. Yes.
Okay. It's an important topic, very, very, very important topic. So for ranking, I told you that we can use rank dot equal or rank dot what? Average. So if we use the AVG method, what does it give us? Let's see how that comes out. Can you see where we have 4 here? It's giving 4.5, 4.5. Okay. Because it's getting the average of fourth and fifth, which is 4.5. It gives each of them 4.5. But this is the standard method. Okay. But just in case that is needed, that's how that goes.